Another great example for this part, problem 142. This is a very good problem, and if you are not really familiar with this topic, this is going to take a little bit time for you to solve it. So I would suggest to spend at least half an hour on this one. Try your best to solve it before seeing the rest of the video. So what we have here, we have this arm, which is rotating in counterclockwise direction with angular velocity of 4 radian per second. There is a pin stick to this arm, and also from the other side, it is moving on this slot, on this sector. So whenever we are rotating this bar, because of this pin, we are gonna push this, and this sector is gonna rotate too. The angular velocity of this arm, BC, is 4 radian per second, and it is constant. There is no acceleration for this arm. The question is about what is the angular velocity of this sector, ODE, and what is the angular acceleration of it. So we want to find omega and also alpha of this part. So after trying your best, as I said, at least half an hour, then come back and see the rest of the video. So to solve this problem like the previous one, I'm gonna stick a coordinate to this sector. And you can do it in different ways, but at the end, all of them are gonna do the same thing for you. What I'm gonna do here, I'm gonna use this XY direction, which is stick to this sector. So this XY, at the moment, they are in the horizontal and vertical direction, but a moment later, they're gonna rotate with this sector about point O, and they're gonna be in different directions. So this XY is stick to this rotating part. And the origin of it is O, and it's gonna rotate with this. So if I find omega of this XY and alpha of it, it's gonna be omega and alpha of this sector. They are the same thing, right? So I know this link is rotating with angular velocity of n, 4 radian per second. So from there, I can find the velocity of A. Velocity of A is going to be r times omega, or r times n here. So it's going to be 4 times 0.12 meter. And the direction of the velocity is going to be in the x direction. From the other side, if I want to find the velocity of this point using the rotating frame of xy, I can use that velocity equation that we learned for rotating frames. It's going to be velocity of O plus velocity of A relative to this xy coordinate plus omega cross r, which is OA here. From there, like the previous problem, you're going to have two equations and two unknowns, and one of the unknowns is omega of this frame. So that's the way to go. So let's just start with this. Velocity of A is equal to n cross CA, which is going to be 4 times 0.12, and the result is going to be in the I direction. So let me just write the result. It's going to be 0.12 times 4 radian per second, which is going to be 0.48 in the I direction. This is the actual velocity of pin A, actual velocity of it. And from the other side, velocity of A is equal to velocity of O plus omega of xy coordinate cross OA plus V rail. And V rail here means velocity of this pin in xy coordinate. If you sit on this sector, which means your coordinate is xy now, and look at pin A, you're going to see A is moving on this slot, right? Let's say you don't know you're rotating and you're just looking at point A. You're going to see A is moving in this direction. And that velocity that you are seeing is the v-rail. Now look at this equation and see how many unknowns do we have. The actual velocity of A, we have it, we just found it, right? Velocity of O is 0, this is pinned to the ground. Omega of this sector, omega of xy coordinate, it is unknown, but we know the direction, is k. OA, we know this vector. V-rail, we don't know the magnitude of it, but we know the direction. This is the direction of the relative velocity, right? So we have only one unknown here. So at the end, I'm gonna have two equations, two unknowns. Let's write down everything. Velocity of A is 0.48 in the I direction. Velocity of O is 0. Omega is omega in the K direction. It's unknown. Cross OA, 0.12 in the I direction, plus V-rail. Any vector is the magnitude times the direction, right? So the magnitude is unknown, but the direction, this direction, you can write it in terms of I and J, right? Let's say we have a unit vector in this direction. That unit vector is going to be cosine of this angle times I, sine of that angle times J. And this angle is 45. So the direction is going to be cosine of 45 the I direction plus sine of 45 in the J direction. Now, if I separate I and J terms, then I'm done. But before that, let's do this cross product. K cross I is J. So this is all together is going to be 0.12 times omega in the J direction. Now, if I separate I and J terms, for I have 0.48 here. In the other side of the equation, I have only this one, V rail times cosine of 45. So from this equation, I'm going to be able to find the relative velocity. The relative velocity of this pin in the xy coordinate. Again, it means if you sit on this sector and look at A, you're going to see it is moving with this velocity in this direction. And V rail is going to be equal to 0.48 times square root of 2. Because cosine of 45 is 1 over square root of 2. Right? We can actually calculate this number too. I don't have it in my notes. And the unit is meter per second. And for the J direction, we have nothing on the left side of the equation, so 0 is equal to, I have 0.12 times omega, and I have V rail times sine of 45. And we know what is V rail from the previous part. So if you plug it in this one, we are going to find omega, which is going to be equal to -4. It turned out to be negative. It means it is in clockwise direction. So we found omega. We found the angular velocity of xy coordinate, which means angular velocity of this rotating part, that sector. Now, for acceleration, we can do exactly the same thing for acceleration. We need to find the acceleration of A first, the actual acceleration of it, which is quite easy to find. Why? Just imagine there is no sector here, right? A is a pin which is on this rotating arm. So A is moving on the circle with the center of C. So the acceleration of it is going to have two parts. Tangential part, which is r times alpha. Alpha means angular acceleration of this part, which is 0. So acceleration of A in the tangential direction is 0. But angular, we have normal acceleration too, because again, A is moving on a circle with this center, right? So actual acceleration of A is going to be equal to r times omega squared, omega of this r. And the direction is going to be toward the center, which means in the j direction. So it's going to be 0.12 times omega squared, or n squared, which is 4, right, times 4 squared. And it is all in the j direction. So 16 times 0.12 is going to be 1.92 meter per second squared, and it is in the j direction. This is the actual acceleration of this point A. Now, if you look at it from the other side through this rotating frame, acceleration of this point is going to be acceleration of O plus other terms that we had in that equation. Let me write it down. Acceleration of A is going to be equal to acceleration of O plus relative acceleration plus omega cross R, which is OA here, plus alpha cross R, or OA, plus the Coriolis acceleration, 2 times omega cross relative velocity. Now let's see what we have and what we don't have here. Acceleration of O is 0. The relative acceleration, again, what's the meaning of relative acceleration? It means if you sit on this sector and rotate with it and look at the point A, what you are going to see about point A, about the acceleration of it. You are seeing A is moving on this slot, right, in this specific direction. So the velocity and also acceleration of it is going to be in this direction. The magnitude of that acceleration is unknown, but we know the direction. So this relative acceleration is going to be A rel times this unit vector times that direction. So we are going to have only one unknown here. Second part, or third part, omega, we found it in the previous part, so there is no unknown here. Alpha, we don't know the alpha, but we know the direction is k, like any other 2D problems. So we have another unknown here. Omega and v rel, again, we found it in the previous parts. So we have only 2 unknowns here. Again, 2 unknowns, and we have 2 equations. So everything is fine now. Acceleration of A, we found it here. It is 1.92, all in the j direction. A rel, again, we don't know the value of it, but we know the direction. The direction is cosine of 45i plus sine of 45j. Omega cross OA, again, this is because it's a 2D problem, it's equal to negative omega squared times OA, just to get rid of those cross products. So it's going to be negative omega squared, negative 4 squared, times OA, and OA is 0.12i. Plus alpha cross OA, alpha is unknown, but the direction is k, cross product to OA, which is 0.12i, plus 2 times omega cross v rel. So it's going to be plus 2 times omega is negative 4 in the k direction, cross product to v rel, and v rel is this number, right? So cross product to 0.48 times the square root of 2 times the direction. We need to write it in vector form. And the direction is cosine of 45 I hat plus sine of 45 j hat. So we need to do this cross product here and also this cross product. I cross k is negative j, and same thing here. We have k cross I and also k cross j. You can do those cross products, then separate I and j terms, then find the unknowns, right? So let's do all of them together. This is gonna be this part. Let's write it here. K cross I is j, so I'm gonna have 0.12 times alpha in the j direction. And this part, 2 times omega cross product to V rail. And we have K cross I is J, so this part, including this. It's a little bit messy, sorry about that. So K cross I is J, 2 times 4 times this times cosine of 45. Cosine of 45 is 1 over the square root of 2, so this is going to cancel out. So I'm going to have 8 times 0.48, and we have that negative sign too. So negative 8 times 0.48 in the J direction. And same thing for the other part. K cross J is negative I. We have it on the negative here, so positive 8 times 0.48. Again, the square root of 2 times sine of 45 is going to be 1, right? And the direction is, again, K cross J is negative I. We had another negative. Now I can separate I and J terms and find unknowns. In the I direction, we have nothing here, 0. In the other side, we have A rail times cosine of 45. Then we have this part, negative 16 times 0.12. Then we have this part, plus 8 times 0.48. So from here, we are going to be able to find A rail. And in the J parts, we have 1.92 here. In the other side of the equation, we have A rail times sine of 45. Then we have this part, 0.12 times alpha. And also we have this part, negative 8 times 0.48, which is in the J direction. 2 equations and 2 unknowns. You can simply find A rail from the first one, put it here. You're going to be able to find alpha. Right? So if you do that, A rail should be negative 2.72 meter per second squared. And alpha is going to be equal to 64 radian per second squared. So alpha is going to be in counterclockwise direction.